Okay. Today's video is going to go through a relatively quick review of sine law and cosine law and our application of it to be able to go through and solve triangles. But the other focus for us today is to get maybe a little bit of a deeper understanding of what sine law is and definitely cosine law, and then also to be able to work through in terms of how do we represent our solution and what are expectations within your solution. So the first thing I'd like you to notice is if you take a look, we have both representations of sine law and cosine law listed on the screen. Sine law, you recognize, simply states that the way any side length compares to the sine of its corresponding angle is equal throughout a triangle. And so side A compares to sine of A the same way as B compares to sine of B and C compares to sine of C. Therefore, all corresponding sides and sines of the angle are equal throughout the triangle. When we go through and we try to use sine law, very rarely, if ever, do we use three ratios to be equal. And quite normally, you've now taken two of those ratios and use them to solve for a missing side or angle. My recommendation to you, where you see reciprocals written on the right side, is whatever you were looking for, put that on top. So if you're looking for a side length, then let's use the form of sine law that puts sides on top. And if you were looking for an angle, then let's use the form of sine law that puts angles on top. Just a recommendation, never needed. Next, let's take a look at cosine law, one of those uglier formulas that you would have been required to know at a grade 10. I want to jump a little deeper into what cosine law is so that it becomes not just a formula for us, but we can actually understand maybe a little bit better where it comes from and maybe a little bit better its application. So what you'll notice is that cosine law starts out with a form of Pythagorean theorem. And then the last term that we have is often referred to as an adjustment. And so as we work our way through, cosine law is a right triangle relationship that's used in non-right triangles. So therefore it requires an adjustment. So I'm going to put down a very, very quick diagram of us dealing with a right triangle. And that form would state that this must be A, and this B, and this C, for my A squared to equal B squared plus C squared. Now, if we can get a little bit deeper understanding, I'm going to ask you to take out your calculator. And what I'd like you to do is simply make angle A 90. And so, on your calculator, I'd like you to punch in the cos of 90 degrees. And what you'll notice on your screen is that's going to equal a value of 0. And so, in my adjustment, back in cosine law, my cos A is going to equal 0, which will wipe out that entire adjustment, and I would be left with my Pythagorean theorem. Okay, now what we're going to do is we're going to start to change that cosine law, or that triangle, away from a right triangle. And so what I'm going to do then is I'm going to take angle A and I am going to make it less than 90 degrees. So maybe that's the location of C. So what I want you to do is just pick any angle for A that's greater than 0 but less than 90. So for instance, maybe I just punch in like, hey, the cos of 30 degrees. And when you punch that into your calculator, you'll notice you get a positive decimal value less than 1. And so this cos A then becomes a positive value that when I multiply it by a C, a side length, and another B, a side length, and then multiply it by -2, that's going to give me a negative final term that I will subtract from my Pythagorean, which gives a little understanding then for why my side A is a little bit shorter. It would be Pythagorean, making that my hypotenuse, subtract a bit. So maybe that gives a little bit better understanding then for us to be able to work through and see. Lastly, though, and I think what's really going to give us a good understanding to this is what would happen if we made angle A bigger than 90. And so maybe that's the location of C, which would form that as my triangle. What I'd like you to do is now, in your calculator, pick any angle value that's greater than 90 and then less than 180 because it's got to fit inside of a triangle. So maybe I go ahead and I punch in like cos 150. And what you're going to notice on your screen is you're going to get a big ugly decimal, but it's going to be a negative value. And so if I jump back up into gold, up in my adjustment factor, this cos A is now a negative value that when multiplied with the negative on the 2 is going to mean my adjustment becomes a positive value. And so I'm going to take Pythagorean theorem that is going to make the length of my hypotenuse A, and now I need to add some stuff to it to make it longer. We should be able to take a quick peek at that very crude diagram and see how we take our cosine law and we adjust it for non-right triangles. I'm hoping that that gives us a little bit better of an understanding of what cosine law represents, but I don't want us to memorize that formula. Hopefully we can recall the relationship. So we should be able to use Pythagorean plus the adjustment and build any form of cosine law that we need. So imagine that what we ended up having in our relationship was our b squared side isolated. Hopefully we can look and say, well, the beginning of cosine law is Pythagorean, so I need the sum of the squares of the other two sides, and now I need my adjustment factor. So I need to subtract off 2 of those sides, cos of the side that's isolated. What I'd like everybody to do is pause the video for a second, and I would like you to write out the form of cosine law that would have the c squared isolated on one side. Okay, we're back. And hopefully if we have the c squared by itself, then that means that you have the sum of the squares of the other two. And now our adjustment, subtract off 2 of those, cos of the side isolated. Hopefully that gives us a little bit of a better grounding on what sine law, cosine law are, and a little bit more understanding as to how we can use it. So what I want to look at right now is us going through and solving two triangles. So the first one I want you to notice is triangle ABC on the left. And we should be able to take a look at that. And the first thing we notice is that it is not a right triangle. So if it's not a right triangle, then you have two tools at your disposal. We can use sine law, we can use cosine law. So what is it that you're looking to find? Well, the first off, we need to recognize we need to find angle A, we need to find side A, and we need to find side C to solve. I would hope that everyone would find angle A first, that being 180 minus the sum of the other two. And just like when we're going through and solving, you don't have to show us all that work. We don't need to see. If you simply come in on A equals 51, you're good. But remember, don't just label that on your triangle. You have to list out all the missing properties. Now that we know that that's 51, feel free to label it on your diagram, but never needed. Okay, now to be able to work our way through, I'm going to go through and look for what information I have. And I would hope that when we take a look, if our options are between sine law and cosine law, we would prefer to use sine law. It's a little bit easier to work with. But the key for sine law is, do you have an angle and its corresponding side? And because I have both b's, that's going to become my fraction, my ratio in sine law that's going to be key. So if I was to work through, then I can use both of those to perhaps find my A. So I know that A compared to the sine of angle A must equal B compared to the sine of angle B. Notice I'm looking for a side length, so I chose to put side lengths on top. I did that because my next line now will show me multiplying out the sine 51. And now, since we don't talk about side lengths that way, we're going to have to push some buttons and calculate that. We're finding a side length, which means we round to 2 decimal places unless stated, put on our units, and we're good. We would need to see all 3 of those lines in our solution. The first line is the application of sine law. The second line is the exact theoretical length of A. But because we don't talk about it that way, we then need to round it off to our approximate value in the end. We would need to see all 3 lines. Okay, lastly, we're going to work our way through to be able to go through and find the last missing side, that being side C. And so, to find side C, that would be my side over the sine of the angle. And I'm going to keep using that key fraction, that key ratio, my b's. Now I can multiply out my sine 72. And I'm coming in with an approximate value of 20.41 centimeters. And there we go. So a very quick review on how we can use sine law to go through and solve a triangle. Now I'm just going to put a little wavy line down here to divide our next solution, and I'd like us to take a look at B. The first thing I'd like you to notice is that triangle B does not have any labels on it. So let's go through and let's label that triangle. So maybe I'm going to call this D, E, and F, just to move away from A, B, and C the whole time. Now, for us to decision make going through this triangle, the first thing we notice is it's not a right triangle. I can't assume it is one. And so I can't use Pythagorean theorem or any of my SOHCAHTOA. The second thing then is I have sine law or cosine law at my disposal. I prefer to use sine law. But when I scan through all the information on the problem, I have side E, but I'm missing angle E. I have side D, but I'm missing angle D. And I have angle F, but I'm missing side F. That I do not have a side and its corresponding angle. And therefore, I can't use sine law. And if I can't use sine law, then I'm stuck using cosine law. Now, there is a shorter way for us to be able to identify the use of cosine law here. And it's a small acronym that if you've got a pretty decent memory, then you might choose to remember the acronym SAS, or side angle side. That anytime I have a side, another side, and the contained angle, then that becomes a cosine law application. And so if I recognize that I have side angle sine, then I can be a little bit quicker to say, okay, I know I'm going to use cosine law, and I can work my way through. So the first thing I may do is I'm going to write down my form of cosine law. That's going to allow me to solve for side F. So I'm going to put side F all by itself. Well, to finish out this version of cosine law means I need to have the sum of the squares of the other two. Then I need my adjustment factor. So subtract off 2 of those, and cos of the angle. Notice I put that in blue. I would never need to see that line in your solution. The next line you may choose to put in, this is really depending on comfort level, is going to be substituting in your side D, your side E, wherever that relationship says. Notice I still kept it in blue. Never needed. I am going to put the next line in green. This is a line that is never needed. However, I would strongly recommend that you include it, because it becomes a nice line that if we get down to the end solution and something doesn't quite make sense and you feel like you could have made an error somewhere, that green line I put down is a nice, easy line to be able to take, look back to your original diagram, and see if your information matches up. The first line that we would need to see in your solution would be you going through and saying, okay, I'm going to collect my two terms that I can. My 121 plus 100 is 221. I can't collect it with the negative 220 cos 80 because those are different terms or unlike terms. And I can get rid of my squared by taking the square root of the whole thing. That is an exact value for what the length of f is. We need to see that. However, we don't talk about it that way. So if you turn that into a decimal approximate, or finding a side length rounded to 2 decimal places, you're good. All you would have to show is the red lines. Now, if we take that and we have now found that side f is 13.52 meters, we have cured our problem. You'll notice that you know both of the f's, the side and the angle. And if you do know that, then we can use sine law to work our way through. So for us to be able to work our way through now, we need to find angle D or angle E, and I'm going to give you a little suggestion. This suggestion might come into play a little bit later, where we really understand why we do it. But when you ever have a decision to try to find two missing angles, always find the smallest angle first. It's just a suggestion, but it's going to keep you out of trouble. And so in this case, because I take a look at the side lengths, I have a side length of 10 or a side length of 11. I know that sides create opposite angles. And so my smaller side of 10 means that angle E would be the smaller angle, smaller than D. And so I'm going to go through and I'm going to find angle E first. So I'm going to use sine law and I'm going to put my angles on top. I know both of my f's, so I can substitute those in. And now I can get my sine E all by itself, which means multiply out my 10. And now we need to go backwards and find the angle. If you wish, you can include this line, that E is going to be the inverse of 10 sine 80 over 13.52. However, you don't need to show that. You can simply go ahead, take 10 sine 80 divided by 13.2, and then do the inverse sine of it, and we should come in on 47 degrees. You're solving for an angle, and our generic rounding rules are solve to the nearest degree. Now that we have that angle E found, now we can go ahead and we can find D, because you know that D is 180 minus the sum of the other two. My mistake. And just as before, make sure you show us everything in red. So there is a very quick review for us to be able to go through and see how we can apply sine law and cosine law to two triangles. What we're going to do now is we're going to kind of play around with two different triangles. I'd like you to take a look at the two triangles that I've put on the page. And the question itself asks, which would you use, sine law or cosine law, to begin solving each triangle? And so really what we want to do is we just want to focus in on the decision that we're making as we begin that process to solve. So the first thing I might do would be to label my triangles. And maybe I call that A, B, and C again. For me to take a look, one of the key things is I've been given two angles. And anytime I've been given two angles, I've really been given three. Because I know that that third angle has to be 180 minus the sum of the other two. And so if I have my 180 and I'm subtracting 125, well then I know that angle B is 55 degrees. And now that I know that angle B is 55 degrees, you should be able to tell me which you would use first, sine law or cosine law. And because we have an angle and its corresponding side, we should be able to go through and use sine law. What I'm going to do is I'm going to let you finish off solving for triangle ABC, or question 2A, and we'll see if we match up in the end. But before we get to that, what I'd like you to do is take a look at B. When you take a look at B, we have another triangle that's not labeled. So what we're going to do is we're going to go through and we're going to label it. And if I was to go through and label, then maybe I call this one X and this one Y and this one Z, just for some variety. Now, quick glance, you'll notice very quickly, it's not a right triangle, so I can't use Pythagorean or SOHCAHTOA. And I haven't been given one angle. So if I haven't been given one angle, then I don't have a corresponding angle and a side. And so when we take a peek at that, our decision at the very beginning should have been cosine law. Now, just as we discussed earlier, there's actually a little acronym for us to be able to work our way through on B. That for me to start off that problem, I actually very quickly know that I'm going to end up using cosine law because I've been given side, side, side. There's another one of those acronyms, similar to before, but it identifies for me that anytime I've been given side, 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 the three sides of a triangle, then I'm going to use cosine law to find a missing angle. So we're going to go through this one together because there's going to be a slightly different process for us to go through. So the first thing that I'm going to notice is anytime I go to find a missing angle and I have multiple options, I'm always going to find the smallest one first. And as I identify small sides, give me small opposite angles. So since side Y is the smallest, that means angle Y must be the smallest. I'm going to now use cosine law to find angle Y. That means I need to put down side Y all by itself. So let's pause the video right now and see if you can finish off your version of cosine law. Okay, we're back. As a little bit of a check, what we have is y squared all by itself, which means that we have the x squared plus z squared, finish off Pythagorean. Then I need to adjust it by subtracting 2 of those cos of my angle. And if you take a peek at that green version of cosine law, you'll notice there is angle y. I just have to get that all by itself. So, first line that we may be comfortable working with would be, let's sub in everything and square it. So, if I sub in my 17 and square it, I get 289. If I sub in my 19 and square it, I get 361. Sub in 23 and square it, 529. And then over here, I've got my 2 times my 19 times my 23 cos of y. If I was then to go through and collect the 2 first terms, I know I can't collect the last term, but I can at least simplify it. We get to a very dangerous point And I'd like everybody in their solution to just put down here right now, be careful. Because a real common mistake is to go and take 890 and subtract 874. When you do that, we're going to come in with 16 cos y. And you will have then made a mistake that does not allow you to finish solving the problem. If there's any doubt on that, go ahead and take your next line and take 289 and divide it by 16, and then take the inverse to try to come up with what angle y is, and you're going to find you cannot solve for y. So I want to make sure that we're good, that we avoid all of that blue writing as we go through. That when we take a look at trying to solve for y, we're going to recognize that the two terms on the right side of that equal sign are not like terms. And so what I can do is I can then get rid of that 890 and then divide out my negative 874. That's going to get me to a cos of y being equal to 601 over 874. And we can then take the inverse cos and we can come in on a value of approximately 47 degrees. After you have angle y, we should be good to finish it off, and you should be fine to go. So what I'd like everyone to do is just pause the video now and finish off solving both triangle A and B, and we'll see if we match up in the end. Okay, and we're back. And so what you'll see written on the bottom of the page is our approximate values for F and D, and then you'll see your approximate value for angle X, and we should have been able to solve for angle Z. Notice in your solution, though, we should probably not have an approximate symbol over that because we would have used 180 minus the sum of the other two angles. So now your job, jump in, work through on that practice, and make sure that we're pretty comfortable dealing with sine law and cosine law to be able to solve triangles. Good luck.